Hi, sixth graders. This is Mrs. Newsome. So today we are going to tackle a new math lesson, and we're going to start right in our journal. There's nothing for your interactive notebook today. Today we are doing something called ratio and rate tables. So I'm going to have you turn in your journal to page 97. And this is where we're going to get started. So, over the last few days, we've talked a lot about ratios. And ratios, there's that word, is just a comparison of two quantities, two numbers. And rates are very similar. There's just one kind of small little difference. And the math message today is going to see if we can identify those differences. So I'm going to kind of walk you through this and see if we can identify what makes a rate different than a ratio. So I'm going to kind of split this down the middle for a second. So this side says these ratios are rates. Okay, so this side, these are rates. And if we see this, it says 12 inches per foot, $3 per pound, 6 inches every 2 years, 100 miles for 4 gallons. And you'll notice that I highlighted the units there because that's what I'm wanting you to pay attention to. All of those rates can be written as a ratio, 12 to 1, 3 to 1, 6 to 2, 100 to 4, but pay attention to the units. Okay? Now on this side, it says these ratios are not rates. Okay? They're still ratios, but they're not rates. Now look at how these units go. 3 children out of 8 children. 4 tiles for every 7 tiles. 5 miles out of every 10 miles. 12 stamps out of every 20 stamps. And again, they wrote the ratio, 3 to 8, 4 to 7, and on and on. What do you notice is different about the units of rates versus the units that are not rates? I'll give you a second to think. So what I'm hoping you're noticing is that a rate has units that are different. So 12 inches per 1 foot, $3 per pound, 6 inches every 2 years. Notice that the two numbers that they're comparing have different units. That's what a rate is. If you look at these things that are not rates, that are just ratios, it's children to children, tiles to tiles, miles to miles, stamps to stamps. Ratios compare two quantities, and they could be numbers that are the same and numbers that are not. But to be a rate has to, and we're going to write this down, a rate compares two numbers with different units. Okay, so it's like miles per hour, inches per foot. It's like you're comparing those two things. And so today we're going to be working with ratio rate tables. We're going to be comparing things with different units and solving some problems with those. So let's take a look at how this goes. So it says the problems below involve some common rate situations. Draw a ratio rate table. Now this is something that's new to solve the problems. And then we're going to circle a unit rate for each one. We'll talk about unit rate in just a second. Let's focus on this ratio rate table. I'm going to zoom in here. So a table, you guys have worked with tables before. Tables have columns and rows. And so each of these are going to have a little table. And the table is going to be a place for us to look at these ratio and rate comparisons. Okay? And so let's read this first problem. 1 ounce of dry roasted cashews has 165 calories. So I see 1 ounce and 165 calories. That's going to be our rate. Okay? And what we're going to put here at the end are whatever these units are. So we're comparing ounces to calories. Okay? Ounces to calories. And the first one they tell us is that 1 ounce is 165 calories. So we're going to insert what we know into the table. And then it says how many calories are in an 8-ounce bag of dry roasted cashews. So we're going to use this table to try to get ourselves to not just how much 1 ounce has, but how much 8 ounces have? Now, there are two ways to go about this. I'm going to show you kind of two ways. I'll show you the kind of the easiest way first, okay? So some people will say, oh, then I want to know 8 ounces, and they put those 8 ounces right in there. Remember that ratios are, and this is that fancy word again, a multiplicative comparison. So if I'm going to go from 1 ounce to 8 ounce, that is a times 8, right? So if I want to do that at the top, I can do that at the bottom too. And so if I'm going to multiply the top by 8, I also have to multiply the bottom times 8. It's almost like we're making a little equal fraction, right? We're going to multiply 1 times 8 is 8, and 165 times 8 is 1,300. And you see I just did that in my calculator. 1,320. And so basically I just times this rate by 8 to get my answer. And that's usually how I do it if it's just a straight up multiplication. So 1 ounce is this. If I want to know 8 ounces, I'm just going to times it by 8. You can also do this in a series of different steps. And I'm going to show you that one on number 3. Hopefully you're writing this down with me. Now, the other piece here that we haven't talked about yet, it says circle the unit rate, okay? Unit rate is a rate that compares 1 to something, okay? Hopefully maybe you remember a little bit. Let's see. When we did unit fractions, do you remember us talking about that not too long ago? Unit fractions have a 1 on top, right? So that word unit, it means it's got a 1 on top. Well, a unit rate is a rate where one of your numbers is a 1. So if we look at this problem, 1 to 65 is our unit rate because it's got a 1 in it, okay? And that's helpful when you're doing these kinds of ratio and rate tables to find your unit rate because that's usually what makes this an easy multiplication, okay? This one gave us our unit rate to start with. This next one's not going to. So let's take a look at it together. Actually, the only other thing we didn't do here was write the answer, right? How many calories are in an 8 ounce bag? Well, that was 1,320. And we did that with that table. Let's look at number 3. So number 3 says Hank drove 120 miles in 2 hours. So I see miles and hours. And so that's what my units are going to be. Identifying those units are always going to be what we start with. So we're going to do miles and hours. And then whatever ratio they give us to start with, that's what we're going to write here. So this was 120 miles in 2 hours. Okay, so my first question to you is, do we have a unit rate yet? Do we have a ratio there with 1 to something? We don't. But this is 2 hours. It goes 120 miles. Couldn't I just divide by 2? Divide by 2. Divide by 2. And I'm writing so that you can see what my brain is doing. Usually when you're doing this, you might not write all of that multiply divide, but I want you to see what I'm doing. So 2 divided by 2 is 1. 120 divided by 2 is 60. Look at there. Now I know what my unit rate is. In 1 hour, I'm going 60 miles an hour, right? So now the question says, how about 300 miles? What am I going to get to there? So I'm trying to think in my brain, 60 times what might give me 300? Because that's really what I want to know next, right? And if you know your math facts, isn't 6 times 5 30? So isn't 60 times 5 300? Sure is. So if we multiply that times 5, we get 300, and that times 5, we get 5. So it's going to take 5 hours to go 300 miles. And figuring out my unit rate is usually the best way to go there because usually you can find a little math fact that's going to help you. So 6 times 5 was 30, so 60 times 5 is 300. So it'll take me 5 hours to go that length of time. Okay? All right, let's do one more, and then I'm going to set you off on some work to do by yourself today. So on a trip to France, Jorge bought a soccer jersey for 72 euros. The exchange rate was 1 euro equals $1.25, or €1 to $1.25. How much did the jersey cost in dollars? Okay, great question. So let's make our ratio and rate table. And we are looking at euros and dollars. Okay, so I'm just going to use their symbols. And we know that €1 is $1.25. Okay, and then he bought this soccer jersey for 72 euros. Well, I notice that if I just multiply 72 times 1, I get 72. So shouldn't I just on the bottom multiply by 72 to get how many dollars? You see how that goes? Just noticing a little multiplication factor there. So then I use my calculator to do that. So $1.25 times 72 is 90. So that jersey would cost him $90 in American money. Now the only thing I didn't do here was circle my unit rate. That's always the 1, right? So this one here is my unit rate. Okay, so the ratio and rate table is just really, guys, a way to organize these numbers so that you keep things that are the same, kind of in the same row, and to keep that basically organized. Okay, and sometimes you can do it in one step. Sometimes you need a couple steps, and finding the unit rate, if it's not what you start with, is really important. So what I'm going to have you guys work on today is going to be page 98 and 99. You're going to do math boxes today as well. But page 98 is going to have you practice using unit rates. Okay, and this whole page is kind of about a better buy and how much different stores might charge you for something. You are actually going to, let's kind of zoom this back out, submit a picture of page 98 for me to show me how this page went. I'm going to get you started on number 1, and I'm going to leave the rest for you to do. And then you are also going to do math boxes today. You don't have to submit the math boxes. That'll be save that for a journal tour. All right, so let's look at this one. This one says draw ratio and rate tables and use unit rates to calculate the better buy. And then we're going to write an inequality to represent the situation. All right, so let's look at number 1. Are bright bulbs at 4 for $2.48 or beautiful bulbs at 6 for $3.54 a better buy? So let's do 2 little ratio rate tables. So we've got number and money, and we have to do 2 because we have 2 different stores, right? So number and money, and I'm keeping them the same. So this one's going to be bright bulbs, and it is 4 bulbs for $2.48. This one's beautiful bulbs, 6 for $3.54. So neither one of these are the unit rate. And that's what it's giving us a hint at what we need to do. We need to find out how much one bulb would cost at each of these stores. And that is going to help us decide which is the better buy. So over here, if 4 bulbs cost $2.48, don't we just divide by 4 to figure out how much one bulb would cost? Yeah, we just want to find out how much one would cost. So we're going to take that $2.48. We're going to divide it by 4. And we get that one bulb at this store is 62 cents. Okay? Now let's look at beautiful bulbs. They give you 6 bulbs for $3.54. So for that unit rate, we take the $3.54 and divide it by 6, right? We're dividing the money by how many? $3.54 divided by 6. Here, their bulbs are only 59 cents each. Okay? So if we're looking at this, which store gives me the better buy, the cheaper bulb? It's this one, right? Beautiful bulbs. By just a few cents. Now, this inequality. Inequalities are less than, greater than, or equal to. Those are the things that usually this means. So we're going to take our 2 numbers that we found, our unit rates, and we're going to compare them. So 62 cents is greater than 59 cents. So it's wanting you to take your unit rates and then just to write a less than or greater than math equation to compare them. Okay, and this is just kind of getting your brain thinking about a type of math that we haven't done much with yet that's coming soon. So that's my little lesson today. You're going to finish page 98. You've got 3 problems left. And then you're also going to do math boxes on page 99, which is going to review some things there. And then you're going to submit page 98 as your assignment today. I also have a little ratio review for you that is a little Canvas quiz. It's short, but just to see how you're doing with the ratio work. Okay? All right. Have a good day. You can email me if you have questions.